Hello. Now, today we're going to continue on our work in algebra and we are going to be looking at fractions. Anytime we're dealing with fractions, almost anytime we're dealing with algebra, we're always keeping an eye out for common factors that we are going to be able to divide out and make life easier for ourselves. So let's focus on that now. So I've got a fraction here and I want to simplify it. So I'm going to look for what is common top and bottom. What's the highest common factor top and bottom? I'm going to look for the highest common factor in the numbers first, and then the highest common factor in the letters second. So what's the highest common factor in my numbers? It's going to be 3. Highest common factor in my letters, well, there's no x top and bottom. There's one y top and bottom. So 3y is going to be my common factor top and bottom. So then I have 3y multiplied by what is going to give me 30x squared y, 10x squared multiplied by 3y is going to give me 30x squared y, and 3y by what is going to give me 27y squared, well, 9y. If I divide out what's common, so 3y divided by 3y is 1, and I'm left with 10x squared all over 9y. So that's one way to do it. Very good way to do it. Gets us thinking about the patterns in numbers and how to spot them. However, for longer questions, it can be a nuisance to have to try and write out each bit of a fraction in this fashion. So another way of writing this that is perfectly acceptable is by drawing lines through our numbers. So if I take 30 and 27, the highest common factor is going to be 3, so I divide 30 by 3 and I'm left with 10. I divide 27 by 3 and I'm left with 9. I divide above and below by y, and I am back to where I was using the other method. And both methods are perfectly acceptable. So you will get full marks and all attempt marks if I can see, or if your examiner can see, either of these methods being used. So let's go on to adding and subtracting fractions. Now, from all the way back in first year, we know how to add and subtract fractions. We know that we have to get the lowest common denominator, or we have to get the same number on the bottom of both fractions. Well, what's the lowest common denominator of 5 and 7? It's going to be 5 multiplied by 7. In this particular case, there's no easier version of it, so we just end up with 35 as the number we're aiming for on the bottom of our fraction, and we get it by multiplying our two denominators together. So I want to multiply this 5 here by 7 in order to get the bottom line to 35. And in so doing, I have to multiply the top of my fraction by 7 as well to keep the ratio of my fraction the same, to keep the proportion of my fraction the same. And I have to do the same here, multiplying above and below by 5, because I want 35 on the bottom and I want to keep my ratio the same. So multiplying that out, I end up with 28x all over 35 minus 5x. That should have brackets around it. Minus 5x minus 5 all over 35. Important to put brackets around to remind ourselves that we are multiplying everything on the top line by 5. So under the pressure of exam conditions, it's very easy to forget this and end up writing 5x minus 1, which we want to avoid. Now I have a common denominator. I'm able to write down my numerators all along one line, all over 35, because they're both over 35. But there's something important about the signs that should be jumping out of this. I'm subtracting this whole top line. So I'm subtracting 5x, fairly straightforward, minus 5x. I'm subtracting minus 5, which means that I have a plus 5 here. I'm subtracting minus 5, so it's the same as adding 5. Very common way to lose 3 marks out of a question on the exam. Then I mark my like terms and I get 23x plus 5 all over 35. And I can't see any common factors top and bottom, so that's the job done. Now my next problem, the one in the middle of my page here, is just adding fractions again. And I've given this question as an example to highlight what we always look for. First, we're always going to look for common factors whenever we're doing our problems. So this problem is an extraordinary mess if you don't look for common factors before you do anything else. So there's no obvious common factor. Well, there is. There's a common factor of 3 here, but it doesn't help us at the moment, but we might take out a common factor of 3 there. But we've definitely got some factorization that we can do here. I can see a common factor of 2 here, and what else jumps out at me is I have something squared and a minus, so I'm thinking dots. I'm thinking something squared and then a minus. I could be dealing with difference of 2 squares. I could be dealing with dots, and I know that I've got a quadratic here, and I know how to factorize my quadratics. So let's get a bunch of factorizing done and see if we've got any common factors that we can work with top and bottom. So if I've got this here, I have x squared minus 2x minus 8. When I factorize that, and I already know how to do that, I can do it out separate, or I can do it out in the margin, and I find that I end up with x plus 2 multiplied by x minus 4 as the factors of my quadratic here, which I've already gone through with you. And I know that I have a common factor of 2 here, so I take that out and I get x squared minus 16 minus 2 all over 3 on x plus 4. So I've made progress. And here I can see now that I do have dots, because I know that 16 is a perfect square. It's 4 squared. So then I have x plus 2 on x minus 4 all over 2 on x plus 4 by x minus 4 minus 2 all over 3 on x plus 4. And you can see, even though this is a big, complicated looking problem, it's made up of lots of little bits that we know how to do. And a lot of coping with higher level maths is going to be, I can't do this big, scary sum all at once, but I can do a little bit each time. And if I can recognize a bit that I can do, I'm going to do it. And after that, I'm going to do the next bit I can recognize. And now we've done a lot of factorizing. Let's see if we can do some tidying. So here I can see that I have an x minus 4 multiplied by everything on the top line and an x minus 4 multiplied by everything on the bottom line. So I can divide them out. They're common top and bottom. And let's see if that has helped us in our work. So now I have x plus 2 on the top line all over 2 on x plus 4 minus 2 all over 3 on x plus 4. Well, now, what is my lowest common denominator? It's going to be, well, x plus 4 is common to both, so it's going to be 2 multiplied by 3 multiplied by x plus 4. That's the smallest number that all of my denominators divide into, which is what the lowest common denominator would be. It's the lowest common multiple of my denominators. And this is the lowest common multiple of my denominators. So now I want to get this as the bottom line, the denominator on all of my fractions. So what do I need to multiply by here? I need to multiply by 3. And in so doing, I must multiply the top by 3 as well. And here I need to multiply by 2. So I've got all of my multiply, and I end up with 3x plus 6 all over 6 on x plus 4 minus 4 all over 6 on x plus 4. I now have the same common denominator, so I get 3x plus 6 minus 4 all over, I can multiply in my bracket, 6x plus 24, 3x plus 2 all over 6x plus 24. And I can't see any common factor top and bottom, so that's my final answer. Finally, if I have fractions inside fractions, which is going to happen at certain key points all over the maths course, so we need to be able to handle this situation, what we're going to do is write the top and bottom lines of our fraction as single fractions. So at the moment I have a plus 2 over 3 divided by 1 minus a over 4. I want to write this as single fraction divided by single fraction, and we'll see why in a moment. But we want to tidy this up into single fraction divided by single fraction. It's always going to be our first step. So I know that any whole number, any number just written by itself, is secretly over 1. So I have a denominator of 1 there. So I can write this as a single fraction. So this is going to be 3 over 3 to get the denominator to the same here, and the lowest common denominator here is going to be 4 over 4. Sorry, it's going to be 4. So I'm going to multiply above and below by 4 there. And even though that looks quite messy and complicated, it's just adding fractions, even though it's happening in the context of a bigger problem. So if I can keep my head and recognize that I'm not doing anything different, it's just happening as part of a larger problem, I'll be able to cope with the problems. I'll be able to cope with what I'm doing. So now I have a single fraction, 3a plus 2 all over 3, all divided by 4 minus a all over 4. Now, from first year, again, linking lots back to first year, I know if I'm dividing by a fraction, that's the same as multiplying by the reciprocal of the fraction. So what I'm going to do is say that this is the same as 3a plus 2 all over 3 multiplied by the inverse, the upside down of the fraction that I was working with. And now I'm just multiplying fractions, which I know how to do. I can do top by top and bottom by bottom. Life is easy. So now I multiply that out and I get 12a plus 8. Sorry, at this point I would look for any common factors top and bottom that I could see more obviously now that I've done that change, but I can't see any common factors top and bottom, so I'm just multiplying out. Plus 12, sorry, 3 by 4 is 12, 3 by minus a is minus 3a, and that's as far as I can go. Just to highlight in a number example, in case any of you have forgotten this rule, if I had 8 divided by a half, what would that mean? It would mean how many halves were there in 8, and the way that I would be able to get that would be 8 multiplied by 2 over 1. There would be 16 halves in 8 units. So if we're dividing by a fraction, we flip the fraction upside down and multiply. That's what I've used here. So even though this looks an awful lot more complicated than this example, they're following exactly the same logic. So if I can do this, I can do this. So those are the different bits and pieces of fractions that we need for right now.